In today's discussion, we have introduction to derivatives. And to formally start our discussion, let's start with this general rule number 1. The first rule is, let's say we have this. We have the derivatives of x raised to n is equal to, what happened here is, we just simply bring down the exponent n here. Then, let's copy the variable x. And what happened to the exponent is, we minus 1. So we have n minus 1. So that's the first rule. And to understand it further, let's have an example. Let's say we have the derivative of x raised to 4. Our n here is 4. So let's bring down 4. Then copy the variable x. Then, what happened to the exponent is 4 minus 1 is equal to 3. So, that is the derivative of x raised to 4. Let's try another example. Let's say we have the derivative of x raised to 5. So, our n here is 5. So, let's bring down 5. Then copy the variable x. Then, 5 minus 1 is 4. So, the derivative of x raised to 5 is 5x raised to 4. Let's try the second rule, the derivative of x. So, what is the derivative of x? We all know that there is an invisible one here, right? So what happened is, our n here is 1. So we have now 1, then copy the variable x, then 1 minus 1 is 0. And we all know that anything that is raised to 0 is equal to 1. Therefore, the derivative of x is 1, because 1 times 1 is 1. So let's try. Let's say we have this, the derivative of 3x. We all know that the derivative of x is 1. Therefore, we have now this. 3 times 1 is equal to 3. So the derivative of 3x is 3. Let's try another example. Let's say we have d over dx, or the derivative of 4x with respect to x is, so the derivative of x is 1 times 4. We have now 4 times 1 is equal to 4. So that's the general rule number 2. Let's try another general rule. Now, let's get the derivative of a constant. The derivative of a constant is always equal to 0. Why? Let's try an example. Let's say we have the derivative of 4 with respect to x. It is equal to 0. So the explanation here is simply as this. Let's say we have this, d over dx. We all know that anything that is raised to 0 is always equal to 1. So let's say we have this, 4, and with x raised to 0. So x raised to 0 is also equal to 1. So 4 times 1 is also 4. But what happened here is, let's copy 4 and let's get the derivative of x raised to 0. So our n here is 0. So what happened is, let's bring down 0 and x raised to 0 minus 1. And we all know that if we multiply 0 to 4 and to x raised to negative 1, it is also equal to 0. That is why the derivative of a constant is always equal to 0. Now, let's try another rule. By this time, let's have the derivative of a constant and variable combined together. For example, let's say we have this, the derivative of 3x raised to 5. So, what happened here? We just simply copy the constant. And let's get the derivative of x raised to 5. So, the derivative of x raised to 5, let's bring down 5. Then, let's copy x. Then, 5 minus 1 is 4. So, we have this. So, what happened is 3 times 5 is 15. Then, multiply to x raised to 4. So, that is the derivative of 3x raised to 5. Let's try another example. Let's say we have this. The derivative of 6x cubed. So, what we need to do is just simply copy the constant, then get the derivative of x cubed. So, let's bring down 3. Then, we have now x. Then, 3 minus 1 is 2. Then, 6 times 3 is 18 x squared. So, this is the derivative of 6x cubed. Now, let's try another rule. By this time, let's get the derivative of a polynomial. Let's say we have this. The derivative of a polynomial, which is 2x cubed plus 6x squared minus 3x plus 4. So, we just simply apply what we learned a while ago. So, the derivative of 2x cubed. So, let's just simply copy 2. Then, what is the derivative of x cubed? We have 3. Then, we have x. Then, 3 minus 1 is 2. Plus, let's copy 6. Then, get the derivative of x squared, which is 2. Then, 2 minus 1 is 1. So, we only have x here. Then, minus. What is the derivative of x? The derivative of x is 1. So, we just simply put 3 here. And we all know that the derivative of a constant is 0. So, plus 0. Now, let's simplify. We have 2 times 3 is equal to 6x squared plus 6 times 2 is 12. So, we have now 12x minus 3. So, this is our answer. Now, let's try another rule. By this time, we get the derivative of a number or expression with radical. Let's say we have this. Let's say we have the derivative of square root of x. We all know in the discussion of radical that square root of x can be written like this. So we have this. We have 2 here because it is a square and the exponent of x is 1. So, we all know if we're going back to the discussion of radical, if we rewrite it in fraction form, we have this. We have x raised to 1/2, wherein the 2 or the denominator represents the root of the variable x and 1 represents the exponent of the variable x. So, we can rewrite this as this. So, what we need to do here now is just simply apply the derivative rule. So, our n here is 1/2. So, what we do is just simply bring down 1/2. Then, we get x. Then, 1/2 minus 1 is equal to negative 1/2. And we all know that if there is a negative exponent, what we do is just put the value into denominator, then change the negative sign into positive sign. So, what we do is now 1, then 2. Let's bring down x to the denominator so that we have now positive 1/2. And we can now transform this expression into radical. So, what we do is just simply 1 over 2 times square root of x. So, that is the value of the derivative. Now, let's try another rule. By this time, we have the derivative of a fraction. So, let's say we have this. Let's say we have the derivative of 1, then x, 1 over x raised to positive 6. The first thing that we need to do here is just simply convert or transform this fraction into one expression, so that we have this. You have the derivative of x, then what happen if we opt the variable x into numerator? What happened to the variable is it will become now negative 6. Now, let's apply the general rule. So we have n as negative 6, then copy x, then negative 6 minus 1 is equal to negative 7. Now, we can, since x has a negative exponents, we can bring down it so that we have now this negative 6 over x. Because we bring down x into denominator, what happened to the exponent? It will become now positive 7. So this is our answer. Now, let's try another general rule or another rule of derivatives. Now, let's going to talk about the derivative of trigonometric function. But before we proceed to the example of the derivatives of trigonometric function, I want you to be familiar on this rule. The derivative of sine x is equal to cosine x, and the derivative of cosine x is equal to negative sine x. Now, the derivative of tan x is equal to secant squared x, and the derivative of cotangent x is equal to negative cosecant squared x, and the derivative of secant x, let's say we have this, is equal to secant x tan x, and the derivative of cosecant x is equal to negative cosecant x cotangent x. So that is the rule. And I want you to focus on this idea. All trigonometric identity that starts with letter C, cosine x, cotangent x, and cosecant x, all have negative derivatives. So, negative sine x, negative cosecant squared x, and negative cosecant x times cotangent x. So, that is our some trivia or some hints for you. And for us to have this, let's try an example computation on getting the derivative of a trigonometric function. Let's say we have this problem. We have the derivative of 3 sine x minus 6 tan x plus 4 cosecant x. So what we need to do is just simply get the derivative of each term. Okay? So what are we going to do? Let's copy 3. Then, the derivative of sine x is minus, let's copy 6, and the derivative of tangent x is secant squared x plus copy 4. Then what is the derivative of cosecant x rather is negative cosecant x cotangent x. So let's simplify. Let's copy 3, then cosine x minus 6 secant squared x. It will now become negative because there's a negative cosecant x here. So we have negative 4 cosecant x cotangent x. So this is the derivative. Now, let's try another rule. By this time, we are getting the exponential function or the derivative of exponential function with base e. So, I want you to look at this rule. So, if we have we are prompt on getting derivative of a exponential function involving base e, we have this rule. Let's say we have this. The rule here is we just simply copy e raised to u times the derivative of u, the exponent u. To understand it further, let's try this example. Let's say we have the derivative of e raised to x. So our u here is x. So what we have is, let's copy e raised to x and get the derivative of x, which is 1. So what our answer is just simply e raised to x. Let's try another example. Let's say we have the derivative of e raised to 5x. So what happened is we just simply copy e raised to 5x. Then let's get the derivative of 5x. So the derivative of 5x is 5. So we have now 5 times e raised to 5x. Let's try another example. Let's say we have d over dx and the value of e and raised to 3x plus 6. So let's copy e raised to 3x plus 6, and our u here is 3x plus 6. So we need to get the derivative. So the derivative of 3x plus 6 is times the derivative of 3x is 3, and the derivative of 6 is 0 because it is constant. So we have now equals to 3e raised to 3x plus 6. So that's the derivative. Let's have more example of this exponential function. So let's have this one. So let's try another example. Let's say we have this. We have d over dx e then x raised to 5. So what we need to do is just simply copy first it e raised to x raised to 5, and our u here is x raised to 5, and the derivative of x raised to 5 is what we all know is that, let's copy 5, then copy x, then 5 minus 1 is 4. So what we have now is 5x raised to 4 times e raised to x to the 5th power. So that's our answer. Let's try another example. What if we have this d over dx, or the derivative of 4e raised to x raised to 5. What happened here is just simply, first let's copy 4e x raised to 5. Then our u here is x raised to 5 again, which is we all know that 5x raised to 4. So what we have now is we have now 20 x raised to 4 e raised to x raised to 5. Now, let's try another example or general rule about derivative. By this time, we have logarithmic function. By this time, we have the derivative of logarithmic function. But first, let's have this rule. We have the derivative of ln u is equal to the derivative of u over u. And to further understand it, let's try an example. Let's say we have the derivative of ln x. So our u here is x. So the derivative of x is 1, and let's copy x. So that's it. Let's try another example. Let's say we have the derivative of ln x squared plus 6. So, our u here is x squared plus 6. So, the derivative of x squared plus 6 is we have the derivative of x squared is 2x and the derivative of 6 is 0. So, we have now 2x in numerator. And let's copy the u, which is x squared plus 6. So, this is the derivative. Let's try another example. What if we have this given? We have now 3, then ln 4x plus 3. So our u here is 4x plus 3. And the derivative of 4x plus 3, let's have this. The derivative of 4x is 4 because the derivative of x is 1. So we have now 4. And the derivative of 3, which is constant, is 0. So we have only 4 at the numerator and copy the u at the denominator, which is 4x plus 3. But this is not the final answer because we have 3 here. We have 3 here. So what we do is just simply multiply it. Let's multiply it by 3. So we have now this answer. We have 12 over 4x plus 3. So this is our answer. So that's the end of the discussion. Thank you.